Okay, so today we are going to discuss a series of lectures on Internet of Things. During this series we are going to show you using of different devices and how you can program them with AI and make them intelligent, because today the world is full of Internet of Things. There are so many IOT devices which are getting deployed. The question now is that how do you make these IOT devices intelligent? How do you incorporate AI into these devices? And we are going to do this very practically and explain to you how to do this in a very stepwise manner. These series are going to be pretty elaborate and will require you to work with us as you listen to these series. So, going forward, I will first talk about the background and motivation for doing these, and then we will get into the architecture and all of that. So, let us move on. Okay. So, the current or the earlier day IoT architecture used to look something like this. Now, I would like you to pay very close attention to this architecture, because this architecture has changed, or we are trying to change it pretty substantially, and we will understand why we are trying to change it. So, in an earlier time we used to have devices, IoT devices, which would be in a car or could be anywhere, and then we used to have the cloud, and then obviously there would be the users. So, when it came to adding intelligence to devices, certain amount of detection would happen on the device. That is, for quite some time now IoT devices have been capable of recording us, are capable of having a camera, but the problem used to be that though they were capable of recording audio, also they were capable of seeing images, they were not able to recognize what they were hearing or what they were seeing, and therefore they could not take any action. They had to perforce send this data at a very high cost, and we will see what are the consequences of that, to a program on the cloud. The AI ML program or the AI ML architecture or infrastructure used to be hosted on the cloud. So, it was as if the IoT device would take the picture, would activate the camera and take the snapshot, but it would not know who it is looking at. It would also not know what it is hearing. It is hearing, but it does not know whose voice is it or what is that voice saying. So, basically it had to go and send this data to a cloud. The cloud would then analyze the data, process the data, find out what that voice is saying, find out the keywords in the voice, find out who is there in the image, and then it would send the signal back to the IoT device, and then the IoT device would take suitable action through actuators connected to that. And therefore the user was getting a a substantially delayed experience, and the experience was compromised in terms of a large amount of delay caused because of the cloud. So, cloud was acting as a man in the middle, so to say, and delaying the proceedings. Now, let us just go to the next slide to see what are the consequences of this kind of an architecture. First consequence is latency. Obviously, there is latency because the device is only capturing the image and the device is only hearing the sound or sensing what is happening, but it has no intelligence. So, it has to send it to the cloud. So, obviously, there is delay, and delay is called latency. So, the reaction time of the device would be very limited and that would cause problems. Then the second problem would be reduced bandwidth, because these devices are at the end of the day small devices, though they are capable of Bluetooth, they are capable of Wi-Fi. The issue is their bandwidth is also limited. So they would communicate the image or the voice on a low bandwidth to the cloud, and then the cloud would respond back. So that would take time and that would consume a lot of power, which is what brings to us to the next point, that we need something to do with the energy saving, because lot of the bandwidth is spent or lot of the energy is spent in communicating with the cloud, because the device does not have any local intelligence. It is a small device and it does not have any local intelligence. It wastes a lot of its energy trying to communicate with the cloud, and so obviously the battery life or the usable life of the device diminishes, and most of these devices have to be battery powered. They do not have a regular supply of power. So when they are battery powered and lot of the power energy is spent on basically the communication with the cloud, then obviously there are consequences of that. And then people are scared that the devices are collecting data and communicating it to the cloud. So the cloud in a way becomes a central point of failure, or from a cyber security perspective it becomes a risk, because every data is coming into the cloud, and anybody who can get a backdoor into the cloud can exploit this whole IoT network. Because if there are hundreds of such devices or even thousands of such devices and all of them are sending their data to the cloud and the cloud is analyzing the data, then obviously you are looking at a big security hole in this process, because the data privacy is being compromised or can be compromised. So these are significant disadvantages of IoT which have been listed in literature, primarily because they are low power, primarily because they are not capable of doing local intelligence. These problems have come. Now we will see how these problems are getting addressed today and what kind of technology is used to address these problems. So let us move on and see what is there. So the single most reason or the single most change which has happened is the emergence of platforms and frameworks like TinyML. TinyML stands for Tiny Machine Language or Tiny Machine Learning, and these are basically, TinyML is for example a framework, a machine learning framework. Where does it reside? It does not reside on the cloud. It would not be called tiny if it resides on the cloud. It resides actually on the IoT device. Now first time I saw this, even I was surprised. How can an IoT device which is so tiny and so small be capable of intelligence? But there has been these developments, and we are soon going to show you a device which is capable of doing this ML or TinyML. Obviously we are not going to use the TinyML for training on the device. We are not going to waste the device cycles on training. That will still be done on the cloud, but the decision making, which is what is the actual thing which happens on the IoT, is going to happen on the device, which is the inference. Because remember, in machine learning we always talk about two things. One is training the model, second is the inference engine, which basically once the model is trained, how do you go about taking decisions. So the decision taking is what TinyML is used for, or in simple words, TinyML is not used for training. TinyML is predominantly used for inferencing. So that is what we will do. So our TinyML will run on small devices which are low power devices, resource constrained devices. So this is a remarkable development, because now I can actually make my devices smart and at the same time reduce the energy consumption, reduce any privacy concerns, because the image or the voice or the keywords which are coming in the voice are never leaving the device, they are limited to the device. So if they are coming in my wearable device, they are staying with the wearable device, they are not going anywhere, it is all happening here. So that's pretty big, and so that's what TinyML is all about, and I think it's a very revolutionary thing. And from a student perspective, I think it's very important that you absorb how to do this programming with TinyML and how to enable TinyML on devices, because that is an important skill, because any device has to become smart. It is possible to do that with TinyML. Going forward, what is so special about TinyML? It has TensorFlow Lite and other frameworks. It also supports Android, iOS, Arduino. We can use various programming languages to work with the TinyML framework. Generally Python is the language of choice, but you can use C, C++ and even Java pre-trained models and use them on the device. So that is pretty elaborate. Okay, now I am entering the game where we are going to talk about what device, what specific IoT device we are going to use, we are going to employ in this project series as an intelligent AI capable IoT device. So what is it? Is the device we are going to use. You can see the picture of the device there, and I am holding the device in my hand. This is the device which we are going to use. A picture of that device is shown there, but see how tiny it is. So this is the antenna, and there is a lot of circuitry. We will study that in a moment, and we will see the capabilities of this device also. And this is a device which is TinyML capable. It is coming from the Seed Studio ESP32 Sense, that is what it is called, Seed Studio ESP32 S3 Sense. That is the full name of the device. It costs about a couple of thousand rupees or even less if you buy it in bulk, so you can easily acquire this device and start experimenting with this. As you can see, it has a camera and it has a microphone and quite a lot of things. It has obviously Wi-Fi communication and Bluetooth communication. There can be some slave boards which can be also added to it for sensing motion and all. We will come to that. But basically this is so tiny, so it can go into any kind of a small gadget, and especially if you were to work on a miniaturization project of this can be further condensed. But I think the reason we are introducing this device is, I think it is a useful device and lot of interesting applications can be built on this device. Now you will ask, what is the kind of applications you can build? Well, there is a whole lot of applications, and we are going to show you in these series some of the applications which can be built. But think of it like this, if I am able to see you, not just see you, I am able to recognize you, I am able to recognize what I am saying, I am saying from a device perspective. That means if the device is capable of seeing or recognizing who are you, it is able to hear who are you and recognize what you are saying, understand what you are saying, then the device can do a lot of things. One of the things probably you can make it do is you can say I am so and so, and I mean you do not have to say I am so and so, you show your photo or your mugshot in front of the camera and it knows that it is you. Then you say play me some music, and it can instruct on Wi-Fi some player to start playing some music which is liked by you, because it has from your photo it has understood who you are, from your voice it has understood that you want music to be played. It could be open a door, it could be play a music, and only it will do it for you what music you like, right? So because it knows who you are. There are n number of applications which you could apply. By adding boards to it, you can also recognize gestures, you can also recognize various things which it can do. We will do some project in which we will show you that how to recognize a gesture, how to move like this. You will see projects where you move it in a particular way, it means a particular gesture. You move it like this, it says 2, if I move it like this it says 1, and that can be recognized along with my image, and it is so and so person saying 1, so and so person saying 2, and it can react to it in whichever way it can, and then it just opens up a plethora of applications. If you can get my photo, the person, the wearer's photo, the wearer's voice, and also the wearer's context. Once you get all of that, then you can exploit it in many ways. And as part of this series, we will introduce you to some of the exploitations, not all of them. So let us look at this device in a little more detail. So the device has pretty much quite a lot of circuitry in it. So there is this thing in pink is how to activate the device to touch. It is sensitive to touch also, so you can touch certain pins and make it do things. Then obviously all those pins can act as GPIO pins. This is when I am connecting a peripheral. In some of our projects we will connect a accelerometer or something to this chip as a slave chip and get the I2C, that is the integrated IC communication, and then these pins can also be used in the analog mode or the digital mode, that is the A's and the D's. In addition, we also have the UART communication of this. So you can connect it on a USB and make it talk. That is typically used when you are programming it. So there is a transmit and there is a receive, and then let us look at the backside diagram of this just to appreciate the views of it. So there are these, at a broad level there are these charge LEDs, there is this antenna which is the Wi-Fi and the Bluetooth antenna connector, then there is actually the sense is a daughter board connected on this. So if you see this, this is the kind of a daughter board which is connected onto this device, and that has the camera and it also has the microphone and all of that. So that is a kind of a daughter board which you are connecting. That is how the sense comes. Otherwise it is just the Seed Studio. The Seed Studio does not have the camera and the microphone, it has the sense, so which is what we are using. There are some boot buttons and some LEDs. So let us look at a more detailed view of this. This is the back side, I guess, the back view of the thing. It has the battery charger because you have to have it on the battery also, and then it has the enable pin. Some of these pins are used for debugging, the MTDO, MTDI, MTMS, the MTCK. These are used for debugging your program on this. They are called the JTAG pins, and so we can go ahead. And now having looked at the board, I am just going to comment on how the development happens. What is the development process? So I have a device which is intelligent, which has TinyML on it, which has a whole bunch of sensors on it. So how do I make my application, right? So the way it works is like this. So this is the first step, obviously, is, as I said, the model has to be trained, and then the model can be used on the device. Now depending on the kind of application you are using, the model has to be trained differently. For example, let us say the model has to be trained to recognize pictures. So if the model is to be trained to recognize pictures, then basically during the training process I have to prepare the pictures it is going to recognize, I have to label those pictures, and then I have to create the training model. The training model can be done on a tool. So in our projects, the tool that we expect to use to train is called Edge Impulse. Edge Impulse is a company which specializes in this TinyML training. So we will use Edge Impulse to train the model, and then on Edge Impulse itself we will validate the model. Then once Edge Impulse has created the model for us and we have sent it the data, then we will take the model from Edge Impulse and put it on our device. There might be a conversion required or a library through which the model will come onto our device, and then we will run the inference on the device. This is also called the inference on the edge on the microcontroller unit, which is essentially this. This is where the intelligence will run. So, I am going to just repeat the process. So, depending upon the kind of application you are building, first you need to build the model. That is not going to happen on this device. This device is too tiny and I do not want this device to perish. So, we will take the data, it may be image data, it may be microphone data, it may be CSV data, it could be any kind of data. So, I take the data, go to Edge Impulse, feed the data on it, Edge Impulse creates the model for me, then I validate the model, take the model back. That time I put the model back onto this device and we will show you how, and also then that is called deploying the model, and then my application runs on this device. So, I download the model on the device along with the application which uses that model, and once the application has the model working for it, it can run and it does the inferencing. Now, sometimes what happens, for example, if I am recognizing the gesture, I am teaching it to recognize a gesture. Let us say I want it to recognize the gesture 7, or I want it to recognize this gesture or this gesture or this gesture. What will I have to do? In that case, the training data is not going to come from outside. The training data has to be created as I am doing the action. So, I have to put this in some kind of a data forwarding mode and collect the data. Once I collect the data of my gesture, I label the gesture and I transfer the data to Edge Impulse. This is where the power of Edge Impulse comes. So, I am taking various data of my gesture using my devices and using the accelerometer on my device. I am gathering all the data of my device, I am sending it to Edge Impulse, telling it, hey Edge Impulse, here is my data and here is my gesture. Now build me a model which recognizes this gesture and which recognizes this gesture based on the action. Then bring the model back. So now if I do this after the model has come back, then I recognize the gesture and I can proceed. So that is the story, and that is typically how a TinyML project works. So there are many pieces in that project and that is how they go on.